Hello, good afternoon. This is Mr. Flores and Mr. Diaz, and we are going to be doing question 4 on page 297 in the CPM textbook. I'm going to read the question. When a person is breathing normally, the amount of air in their lungs varies sinusoidally. When full, Karen's lungs hold 2.8 liters of air. When empty, her lungs hold 0.6 liters of air. Her brother starts timing her breathing. At t equals 2 seconds, she has exhaled completely, and at t equals 5 seconds, she has inhaled completely. Find a function that will model the amount of air in Karen's lungs at any time, assuming she's breathing normally. First, we're going to need to find out what's given, which is 2.8 liters of air and also 0.6 liters of air. And also t equals 2 seconds and t equals 5 seconds. And now Mark will be setting up our graph. So on the left side is going to be the liters of air on the y-axis, and for the x-axis we're going to put time in seconds. Thank you for labeling it. And we're going to be scaling it by 0.5 liters. And in the bottom we're going to be scaling it by 1 second. Now, after we have pointed out everything that's given to us, we can put it in the graph, which is 0.6 for 2 seconds. And then for 5 seconds it's going to be 2.8. So there are two types of graphs. There is a cosine graph and there is also a sine graph. The type of graph that we chose was a cosine graph.
So the A equals the amplitude of the graph. The B is the frequency. The H is the shift along the x-axis, and the K is the shift along y-axis. So the amplitude is the minimum and maximum. Minimum slash maximum. That's the amplitude of the graph. So to find the amplitude of the graph, you need to get the given information, which is 2.8 and 0.6. This is your maximum, and this is your minimum. So to find it, you need to subtract the minimum and maximum, which is 1.1. Oh, 2.2, my bad. And then you divide that to get 1.1. There you go. This is your amplitude. From the midline.
Now we have to find K, which is the y shift and also the midline. You need to add amplitude, which is 1.1 by 0.6, the minimum, which is 1.7. And you also do this by subtracting the maximum, which is 2.8 minus 1.1.
Now they're both equal. So these are your K value. 1.7.
Now we have to find the H value, which was actually given to us, which would be 2 seconds. Now we have to find B, but first we need to determine the period, which is 6 seconds. Now we find this by looking at the graph, and as we saw She inhaled and exhaled every 3 seconds. So 1 full cycle would be 6 seconds. Ain't that right?
That's right.
Yeah, that's right. Messing up, man. It's alright, it's alright. We good.
So in order to find the frequency, you need to plug in 6 equals 2 pi over b. Now you have to get b by itself. So you multiply b both sides. So it'll get b6 equals 2 pi. And you divide 6 by both sides. So b equals 2 pi over 6. And you could reduce that or simplify that into pi over 3. So b equals pi over 3.
So, with the given information that we have, we could put together our equation for the graph, which is f fx equals negative 1.1 cos brackets pi over 3 parentheses x minus 2 close parentheses and brackets plus 1.7. That's our equation for the graph.
So in the graph, the function starts at 2.8 since it's a cosine graph. The 3 points are in the graph are 2 and 0.6, 5 and 2.8, 0.6.
We have to find the amount of air in Karen's lungs so she starts holding her breath for 3.5 seconds into a time. We know that 2 seconds she fully exhaled 0.6 liters, and when she inhales for 5 seconds, at 5 seconds it's 2.8 liters. Oops. So we're trying to find out how much 3.5 second is. So we know that between 2 and 5 seconds, the average is 3.5, and we could conclude that the average of her lungs is 2.8. Oops. We could say that 2.8 plus 0.6 will equal 3.4. And when you divide that by 2, it will equal 1.7. So 1.7 liters in 3.5 seconds. And also, you could find this in the graphing calculator too, but I don't have a graphing calculator, so I use Desmos. Right here, I input the equation, and then once you when you want to find out how much she has in her lungs, you just put x equals 3.5 in your calculator or in Desmos, and then you will find the point, which is 3.5 comma 1.7. These are the points of the graph. Okay, now we have to do problem B. find the first time Karen has 2.3 liters of air in her lungs. So basically we could use the equation we found, fx equals negative 1.1 cosine pi divided by 3 x minus 2 plus 1.7. We could use that equation, and instead of using fx, you could just replace 2.3 liters, because since 2.3 is in the y direction, you put that there, and basically you'll be solving for x. So first you gotta you have to get you have to subtract 1.7 from both sides, and you will get 0.6, and that will equal to negative 1.1 cosine pi. I'm using n because I can't find this pi symbol, but don't mind it. So, and then x minus 2, and then after that you divide the whole thing. You divide the whole thing by 1.1, and you will get, oh shoot, you divide 1.1 right here too, and you will get 3 cosine negative 1, and then 5.545 equals pi divided by 3 x minus 5, and then after that you inverse the cosine negative 1.545, and then you'll get 0.9944, and you could simplify that into 0.994. 0.994 equals to pi divided by 3 parentheses x minus 5 parentheses, and then you put pi divided by 3 to the other side. You do keep the change, I think, if I'm not mistaken. It'll be 3 divided by pi times 0.994. That will equal to x minus 5. And then after that, you multiply, and you will get 0.949. You will equal that to x minus 5. And you solve for that, and x will equal to 4.05 seconds. And you could also do this in the calculator too. It makes it easier. It makes a lot of things easier. So you just simply put y equals 2.3, and it will give you 4.051 and 2.3. That's the point of the graph. Well, thank you for watching our presentation.